I'm happy. So, folks, explain to me exactly how the hell I'm supposed to follow that. Yeah, I warned you that I was loud, so turn it down. Because I don't know.
Don't be a rock star.
Oh, shit. I don't have anything to worry about there, man. I'll tell you that for certain. You want to see the opposite of a rock star? We got that covered. No problems. No problems. Fortunately, this talk's going to be significantly less depressing than Nickerson's talk. It's still depressing, but it's less depressing. So, you've probably heard the whole thing about the internet being utility, right? And some people think it should be, maybe regulated, like water or gas. Somehow it's become a part of our everyday life, but it never was designed for that. It was never built to be this utility piece, right? So think back. In 20 years, the internet's gone from something that practically nobody knew about to something we cannot get by without. Upstairs, I'm going through my deck, and I'm listening to somebody sit there, and he's all dejected, and something's wrong, and his buddy walks up and says, "Hey, what's wrong?" He goes, "Oh, man, I can't get to the internet." 20 years ago, some of you were still drinking warm milk, but think back 20 years ago. How many of you actually had an email address? I bet there's a significant portion of people in this room that think real hard. 1995. Okay?
Sounds pretty good.
But you'd be, we went from, can you send me an email? Oh, what? What is that? To can't live without it in that amount of time. But the internet was never designed for this. It was never designed to work this way. So what we've ended up with is this. People who have seen me talk before know this slide pretty well. What's this for people who know? Don't say anything. What's this slide, everybody else? These are all companies that have been popped with data loss due to an application security vulnerability. Every one of them. So I'm here to talk about them. We're going to talk about what vulnerabilities were found and what it means and where they came from. And actually, I'll be honest with you, I heard that the morning talk, there was a lot of really good tech talks. This one isn't. This is actually kind of fun and lighthearted. So get a beer and relax, especially after God, I'm still shaking from listening to Nickerson talk, for crying out loud. This is going to be, we'll still have some groaners, but this will be laid back. So, who am I? I'm Bill Sempf. You can find me on Twitter. That's what the @sign's for. I'm a husband and father. I'm going to try not to keep referring back to Nickerson's talk, but honestly, they usually travel with me to places like this. My son would be sitting in the back of the room giggling at me. We were just at Circle City Con in Indianapolis. Anyone there? Woo! Yeah, I know a couple people were, yeah. My son took a 2-hour class in Aircrack NG from Zero Chaos, one of the devs. He loved it. He's 10. He's a good technician. He's got a Unix server with Minecraft, 2 instances of Minecraft. He's a good technician. He has no clue what he did. He's trying to explain to my father. He's like, so there was a wireless, and I didn't know how to get into it. And then we did something, and then I did. Well, what did you do? I don't know, but it was so cool. So yeah, that's a big part of my life. I'm an author. I've written on, 18 programming books, from Rocks, and then after Rocks folded, then Wiley. I call myself a software composer. This is from a book called Lorem Ipsum by Carlos Bueno. If you haven't read it, I recommend you do. It is, I learned more. It's a 138-page kids book about software engineering. And I learned more about software engineering in those 138 pages than I did in 8 years of college. So I strongly recommend you pick it up if you do. Basically, Lauren is traveling through some fantastic land where each of the worlds is represented by a style of software engineering. So there's the brute forcers, for instance. You just keep piling rocks on top of each other, and then when they collapse under the weight, they just pile more rocks on that. And then there's the composers. And the composers make beautiful things out of beautiful things. And that's how I view myself. I'm no bit twiddler developer. I make things that work out of other things that work and do a pretty good job at it. More recently, though, I've become an applicant. Well, it really doesn't fit up here. All right, well, so a pen tester. I always feel saying that in front of a security crowd. I'm not actually a pen tester. I'm very much in the vulnerability assessment line of work, where I take an application and I find all the flaws in it. It's definitely good security work for a programmer to do, because I've made all those mistakes, sometimes thousands and thousands of times. So it's very easy for me to find them. So a lot of my security experience comes from that. There are people in the crowd that have known me for a long time and knew me before I really was a security person. But about, I don't know, 8 years ago, I just gave up and hung up a shingle and said, okay, I'm a security guy. That's because that's what I do all the time. So I do quite a bit of this. I test people's applications and I have fun with it. Talking about hobbies, I promise I'm not going to refer to as talk the whole talk. But I am a home brewer, but the beer's free here, so whatever. I'm just going to drink theirs. I'm a lock picker. I started the Columbus branch of Locksport International, which is now at the Columbus Idea Foundry, and have a good time. And the Cleveland lockpickers are awesome, so go pick locks. I am a ninja, 5th Cube Anshichuka Ninjutsu, not like a ninja security person, an actual ninja. In the development world, I got a name as something of an insurrectionist. Somebody decided that I'm one of those people who always opens my mouth at exactly the right time to exactly the wrong people about a topic that nobody wants to talk about. Well, as I found out in security, everybody's like that, so it's not really a big deal. But I still have the slide. So we're going to talk about why the web is broken, right? We've got all these exploits, all these things that are happening. What the heck is what is going on? If people are in legit security, I mean in the risk segment or in the infosec segment where you have to decide what applications to use, what not, how to best protect your companies, you've got to be thinking to yourself, what is going on with software security these days? I mean, why is CSI Cyber on TV? I mean, what's with that? So we're going to talk about that, okay? And we're going to talk about it because the history is kind of important. See, there was a time, boy, that is not in focus. There was a time when software vulnerabilities were mostly about vandalism, okay? We were going to, most about vandalism. We are going to throw a digital brick through your front window. That's really what we were trying to do. We didn't like you. You were ugly, you'd done something mean to somebody we knew, so we're going to do something mean to your website and make you look bad, and we made a point, and we got to take a screenshot and put it on our website, and aren't we cool? And that was software security for damn near 15 years for most of us on the web. That was the beginning and the end of it. But then somebody figured out that you can get rich, and now GitHub's a target. Right? So that's what happened. What happened is organized crime got involved. And now, anything that has an identity attached to it is a target. So no longer can you say, my church's volleyball team, who cares about that website, doesn't work anymore. Everything's a target. Because the bad guys are essentially war dialing the internet, looking for flaws, looking for problems. And any time you run across software that's broken, it leaves an entire infrastructure potentially at risk. So, the applications that run the internet are essentially at fault here. Many of you are network people, and I respect the hell out of you because I'm so completely lost in that world. I'd never really done capture the flags before, so I did one, an online one out of California. I don't even remember what it was. It was basically like question and answer format, All right, I'll take encryption for $200, and then you solve the problem, you get points. And I was like, dude, this is awesome, clicking buttons and solving problems, because I know all the technical stuff, right? I can reverse binaries and do all that stuff, no big deal. I just never done it in a competitive format before. I thought that was fantastic. Well, circled around to DerbyCon 2. I go to DerbyCon, and I'm like, I'm going to do the capture the flag. I go up there, I was like, I'm ready. How do you do that? And they give me an IP number. I'm like, what the fuck do I do with this? Anyway, I did figure it out, by the way, eventually. The point is that the networks and the design and the controls and the law and all this other stuff be damned, the software has become the weakest link. And that's because of me and people like me. I mean, it's become a software development issue, and that's the problem. We're writing bad software, and we need to get a better understanding of what the vulnerabilities are that we're building into the software in order to make sure we don't do it again. So that's what I'm here to do, at least a little bit today. we're going to talk about vulnerabilities. All right? So, of course, some of these, you guys are already a security crowd, so some of these you're going to know, but bear with me, I got a different take on them because I'm actually a dev standing up here talking about them. Right? So, SQL injection is A1 on the OWASP top 10, even though only 10% of web applications are vulnerable to it today. Why? Right? Well, have you probably all seen this? Part of the problem is that the majority of the attacks aren't actually showing up on the pen tests, which is where the OWASP top 10 comes from. So guys like Jeremiah Grossman sanitize their data, hand it to the team at OWASP. OWASP counts, SQL injection, 1, 2, 3, 4, 5, 6, right? What is that from? That's from companies that got a pen test. But see, the vast majority of flaws happen in the wild. Organizations that never got a pen test. So even though only 10% of the apps that are being studied are showing up with SQL injection vulnerabilities, there's still a tremendous number of applications out there that have SQL injection vulnerabilities built into them. Don't believe me? Go search GitHub. That's a super eye test. Oh, it's sharper now, though. Thank you, whoever fixed that. What this is this would be a search in PHP for SQL injection, right? So I'm searching MySQL _query and $_get, and with PHP files, 261,403 results. I did this live on Thursday night, last week, and it's up to 280,000 now. Who cares, right? Who cares? I'm not running that software. Yes, you are. Your devs are copying the code from here and pasting it into your projects. Remember the whole composer thing? Yeah, there's a dark side. And this is it. Oh, you can't see that. Good. So what's the risk, right? Well, you guys all know what the risk is, of course. If I find a SQL injection vulnerability, I can download the database. If it's poorly configured under the covers, I can take over the machine quite easily. So it is a much bigger deal than it's being made out to be. It's still out there, and it's still something that people need to watch out for all the time, especially in weird, unique situations like poor Bobby. So let's talk about Facebook. Facebook's one of my favorite topics. Direct object reference is one of my favorite vulnerabilities, actually, because this is something all devs do, right? Developers love numbers. If I have a choice between referencing something with a number or using a GUID, big, ugly string of things that makes it hard to test, always going to pick a number. Always going to pick a number. Facebook picked a number. So you know what the Facebook Open Graph is? It's the web API. So it's a REST-based API that allows you, if you have the proper credentials inside Facebook, to access anything in the Facebook database. So when you go and play, what's the stupid game, the farm game or whatever on Facebook, maybe that's gone now, I don't know, I'm not really a Facebook person, but you go play a game or you sign up for one of the apps that allows you to share pictures or whatever, the developer of that application has access to any data you've put into your account and also probably the data that your friends have put in their accounts. I don't know if you know that. But that's why those applications are somewhat dangerous when questionable people are developing them, which is pretty much today is about all there is questionable people developing them. But that's not what I'm here to talk about. What I'm here to talk about is direct object reference. So this is the basic graph call to a user. The user is the base object inside Facebook. It's the core principal concept, the highest level thing, right? And then users have things like pages and posts and timelines and friends and companies and all this other stuff. So you can reference a user with their Facebook ID, which, believe it or not, is a big int. It's a number. So this happens to be Mary Louisa. And this is, if you're an unauthenticated user, well, you have to have a Facebook account. But she doesn't know anything about me. She doesn't know who I am. She hasn't approved me for anything. When I make a call, I can pull back all of her public information, which, as it turns out, isn't terribly useful. I know she's a Spanish speaker. I know her first and last name and her gender. I know the last time she was on the site, and I know her username on Facebook. Of course, anything you have set public, which I think 66% of Facebook users, at least last number I heard, had everything set public on their timeline, I would then have access to everything. Of course, what's the problem with our 11389 blah, 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 blah number, right? Well, this is the problem. And this is indicative of a lot of flaws in on applications in general today, specifically web applications. In case you can't see, what I've done is I've iterated the last number in that. Now I have a totally different user. But Bill, this means that you could sit and flip through every user on Facebook. Yep. Took me 11 lines of Python. And that's including storing the results in a SQLite database, too. Downloaded about 400,000 users before they finally found me and shut me off. Stop dropping stuff. So what's the lesson learned here, right? Anytime you give the user something that they can touch, you open up all of your data to access if you don't have your authorization set up correctly. No one does, it seems. So there we go. Let's talk about something totally different like Rowhammer. Going from one extreme to another, right? See? Yeah, I don't either. My point is that direct object reference is a super, super easy vulnerability to understand, but the fact is sometimes they get absurdly complicated. A Rowhammer is something, I think I have notes, right? Yeah, DRAM will leak its charge. So this is actually a physics problem. But the underlying software is what causes it to happen. It's because the way the firmware was written. Let's talk about Apple, because it's fun too. Yeah. So, of course, go to fail. A wonderful, wonderful a vulnerability that everybody talked about. Of course, what go to fail caused is people, when an Apple device would go to an SSL site and the checks would fail, it would just mark you as SSL anyway. Which you can imagine is a pretty big deal, though a little difficult to do anything about, but still, if this is a problem inside a very closed down, controlled piece of software, something as simple as this. So, it's a copy-paste error, right? What's going on here is there's a switch statement. I'm sorry, it's a little off the screen. I'd pull it over, but I think it's like wired up. There's a switch statement, and you're checking all these things. And then what happens is, when you get down to this part of the stage, it will go skip over the verify statement no matter what. No matter what's been happening throughout the switch statement. It'll always go and do that. Simple copy-paste error. Code that is, historically, coming from one of the most rigorous code-reviewed organizations in the world. Whether or not that's true anymore is arguable, but historically, and this code, not exactly young code, so even a rigorous process and 10 characters can cause something like SSL to completely stop working on an entire category of devices. That's the pin we've balanced ourselves on at this point. All right? Let's talk about web platforms. MVC is all the rage, for those of you who don't know, largely because of Ruby on Rails. Ruby, and it's not the only one, it's not the first one, but it did make the biggest impact. So Rails is, of course, a web platform for the Ruby language, and it uses MVC and Active Record by default. MVC is basically just a UI stage design model that says that we're going to have some software entity representing our data and some software entity representing our UI, and they don't necessarily know about each other. There's a controller in the middle that controls communication. Okay, and Ruby isn't the only one. Actually, every major platform now has one. ASP.NET MVC is the most popular Microsoft platform now, taking over from web forms. PHP has one, Java has one. They're all over the place. So there's an interesting vulnerability discovered conceptually in the platform. So this is a design flaw in a platform that ended up being a software vulnerability. So in Active Record, there's in Active Record. Yes. So in Active Record, there's a concept that allows you to basically use standardized naming to ease your work with forms. So say I have a new user, new person page, a new member page. As long as I name all my values the same as they were named in the underlying database, then I can just call up a new person, pass in my person form, and it will auto-map everything. So I can, my submit method for the form can be one line of code, right? Because it will auto-map for me. And that's what Active Record does for you. Well, there's this wonderful thing called the mass assignment vulnerability that discovered that I can use 2 lines of code instead, and along with passing in my person form here, I'm also going to pass in a known parameter. Maybe I'll just guess, like isadmin equals true. If there's an isadmin field, it will auto-map it because it's just trying to make your life better. This is known as failing open. So as long as I know what the underlying object body looks like, say, for instance, you're using an open source project, or you're copying Uncle Bob Martin's code like I did for this example here, you probably know what all the fields are called. Even if there isn't a form value on the form for isadmin, I know it's there, so I'm just going to change my JavaScript to set it. When I make myself a new user, it makes me an admin by default. Seems pretty rare, right? No. This is how Igor Homikov managed to commit to the root of GitHub. I mean, commit to GitHub's source code, GitHub's own source code for GitHub. The commit's still out there. It says, how was I able to do this? So, so yeah, design flaw in a framework leading to a vulnerability. Let's talk about web browsers. So web browsers have become a big, big part of our life. Back in the day, you pretty much could just do vandalism, right? Hillary, this is from last election, right? Hillary has 2 elections ago, jeez, oh my God, I'm old. Hillary has her comment field, or her forum up. Somebody finds out that the comment fields of the forum has a cross-site scripting vulnerability, so of course, they load up Obama's web page in there. Yeah. So cross-site scripting is a big deal because the browsers have gotten significantly more complicated over time. Historically, basically what we're doing in a cross-site scripting attack is saving something we know will be executed by the browser in data that then gets returned later. We can do it really any one of 3 ways. We can reflect it from something we control. We can reflect it into the DOM using something we control. Or worst case, like happened on Hillary's forum, we can save it in their database. And then every user who sees it will get attacked. But who cares if people say Obama's site instead of Hillary's? Who cares, right? I mean, aside from those people who do care, who cares? And the issue is how much more sophisticated the browsers have become. The browsers are effectively operating systems now. Even if you're not a dev, take a moment and go look at the document object model in Chrome, in Firefox, in IE, in Safari. They have an immense amount of control over the underlying machine, and a cross-site scripting vulnerability is effectively giving an attacker that user's level of access to that machine through their browser. I can do almost what I want, especially if the user is running as admin, like what 75% of Windows users are doing. So it's downplayed so much because everybody just shows the alert box as a proof of concept. But as browsers become more and more complex, I mean, a Chromebook is basically just a browser running on a machine, right? As they become more and more complex, cross-site scripting becomes a more and more viable vulnerability, and it's on 69% of web applications. Tested web applications. And this goes back to the thing I talked about with SQL injection, right? Where it could be even worse than we think. How am I doing for time? I'm still, it's 2:30, I'm fine. So, much bigger deal than we give it credit for. You probably heard of Heartbleed. Most people didn't even know what a buffer overread was until Heartbleed came around. But of course, XKCD has it nailed. Has anybody seen this comic? Yeah, I figure most of you have. So for those of you who don't know, basically what Heartbleed is when you ping a server, you say, "Hey server, are you still there?" If so, reply yes in 3 characters, and it says yes. If you say, "Hey, server, are you still there?" Reply yes in 500 characters. It replies yes with the next 497 characters in memory. And yeah, so that's a bit of a flaw. But still, once again, one line of code software flaw that leads to what kind of panic, what kind of rewrite? How many of you had to go, How many of you got a panicked page when they figured out and had to go and patch a whole crap ton of machines? Some of you, yeah. I wasn't one of them. Because all my servers are Windows. How often do you get to say that, right? It's true, though. Let's talk about social engineering. Ooh, is the green bar along the top showing me how far I am? Oh, that's awesome. I'm sorry, I've never done this on a Mac before. This is very exciting. Password recovery. So, social engineering is a thing. Here I stand in Cleveland where I'm fairly certain the social butterfly experiment was spawned at Secure State. I'm fairly certain that's where it was. They showed it at DEF CON 15 when they'd gotten it running. And this is the this is one of the core pieces. So the social butterfly experiment was essentially an early way to try to tie together information from a lot of social networking websites to try to help make profiles of people to be able to more effectively attack them. And this was one of the things they put up was the Facebook name game, of course, where you go and find your superhero game by saying your second favorite color, your favorite drink, right? Or your street name, like your favorite ice cream flavor and your favorite cookie. Or your porn name, like your first pet in the street you grew up on. Of course, what are all those questions? Those are password recovery questions. They're bad password recovery questions, but they're still password recovery questions. When they did the presentation at DEF CON, they put this out on a couple of shill Facebook sites, and you know how you can copy notes and stuff? And it had been copied, it had been done 35,000 times. They ended the experiment soon after DEF CON. It's still out there. Last count, I think it was 1.8 million people had filled this out. So if you have a situation where well, never mind. I mean, what do you do in a situation like this? I mean, Sarah Palin fell for this, right? If you're a public person, or if you purposely tell people things about yourself, you're going to put yourself in a position where people can bypass the password, or the forgot password system. The issue is, and this goes back to a core problem with developers, the forgot password process is a solved problem. We know how to do it in such a way that it's effectively unbreakable, even if one part of it falls through. Say, for instance, somebody did fill out the Facebook name game, and we found it using Maltego, and could go and we knew the answers to their questions because we knew the first street they lived on and their mother's maiden name. But the issue is developers are not taking the problems we know are solved and implementing them in a way that we know works. So we end up with this, right? This is a search for the password of the last 4 digits of your SSN. And how many, never mind. So there's, the number of results isn't on that screen. There were a lot, trust me. So this is why we have a problem, people. This is why we have a problem. Let's talk about padding oracles. Right? So we got Poodle. And Poodle is an SSL v3 downgrade padding oracle. But it is not, by any stretch of the imagination, the first padding oracle. Asp.NET has been vulnerable to it twice now. And many other places are. The kicker with a padding oracle, of course, is what you do is you can find out it's like a blind SQL injection attack for those of you who are more familiar with the web side of things. A padding oracle is you depend on either timing or error responses to figure out each character of an encrypted token. And so we go in and we say, is the first character 2? Is it 3? Is it 4? And eventually we get the response back that we want a timing change or an error message change. And we know that that character is right. We can eventually guess a token. So the problem, of course, here is that this is a flaw that keeps coming back, even though we know that this issue exists. We've been researching it. The original paper on the concept was written in, 94? As the internet's gotten faster and more accurate in its own timing attacks become much, much more prevalent. And yet we continue to build them into our software because we don't know. It comes back to a developer education problem. So let's talk about obscurity. Devs love to hide things. I'm going to have to read this because this one isn't my story. Oh, yeah, that's right. Yeah. Oh, shoot. Now, see what I did? So somebody in this crowd, I think, gave me this story. Working a project, doing a base level security scan, just happened to notice that there was an open web port, some obscure port, passing SOAP messages in and out. Didn't know what was going on. Did a little bit further digging, found out that it was financially related. Turns out it was some kind of reporting system from all the POSs and workstations inside the facility that were sending SOAP messages back to a server that nobody even really knew anything about, unauthenticated and unencrypted, with everybody's financial transaction information, the amount of the transaction, the credit card number, the person's identity, everything, just passing in and out through that system. I ran into something really similar with a Windows service that was speaking on port 55498 from a parking lot system, right? So all these various parking lots are out there, and you go and you put in you can pay with your credit card at the parking lot to get a ticket to be able to go into the parking garage. And the way it worked is that the kiosks all were running some Windows app. I have no idea why, some embedded Windows thing, and it was just calling some Windows service inside the server, just over the internet, on port 22,064, sending unencrypted messages, just text string messages back and forth, back to the main server with all the financial information, and that server would check it and then send the ACK back. I needn't tell this crowd that you can't hide things. You can't hide things. Yet for some reason we continue to try. Why? I have no idea. But we do. We continue to put things someplace where people won't notice because it's too difficult to manage the development of authentication, authorization, or encryption to actually protect it. It takes too much time. We don't have the time available. We no longer implement it. We just hide it instead. Or we put our config file up, a copy of our config file with a tilde after the PHP and leave it on the web server. It's all effectively the same. You can't expect to hide stuff anymore. The attackers have automated systems that are looking to find these things, and they do. They find them. And that's part of the problem, not part of the solution. Let's talk about encryption. So this NSA thing's like getting a little out of hand, right? Some guys in Michigan figured out that a well-formed attack can force a website to downgrade from secure RSA to export RSA, right? And even after they announced it, it went from 35%, I think, let's see here. Yeah, 26% of HTTPS servers down to 11.8%. So still 10% of servers are vulnerable here. 1 in 10 still vulnerable. I fear that we've maybe gotten a little conditioned to this whole patching craziness. Oh, the latest vulnerability, we got to go patch everything again and again and again. And whereas organizations that have security people that are that have the infrastructure to stay on top of it might actually be staying on top of things, I think the vast majority of organizations that have servers on the internet have kind of given up. A lot of people have just given up. They you know what? I've got the auto update turned on. That's fine, whatever. I'm not going to check on it. I'm not going to read the logs to make sure things are actually happening. I'm not going to look for a potential error that's occurred in networking 6 months ago and none of the updates have applied. I'm no longer going to do that. Speaking of that, I'm not a network guy, but all of this network equipment just runs on software. The software was all written by people, and it has just as many flaws as the web software. So I was at a major shooting range, let's say, and we're all sitting around. It was one of those things where some security company had invited us up to give us a sales pitch, and then let us, fed us beer. Well, no, let us shoot guns and then fed us beer. Maybe it was the other way around. Anyway, so yeah, absolutely. So what are we doing? We get a bunch of security guys sitting around at a table. What do you do? Well, fire up you break shit, right? You fire up a scanner and you look at their internet. It's like, oh, they got open Wi-Fi, awesome. Yeah. So I'm looking through it. It's like, by the way, this is PAM, P-A-M-N. If you're still on iOS for some reason, that piece of software alone is worth moving to Android. It is fucking awesome. And it's basically just a GUI-based scanner. Go get onto a Wi-Fi, just bang. It's amazing. So I'm looking through these machines. I was like, oh, look at these machines. They've got all these weird ports open and stuff, and RDP ports and these things. It's okay. That's very interesting. I start scrolling down. So all these machines in this network. I was like, God, everybody in this room must be on the wireless. Then I start looking at the machine names: POS1, POS2, POS3. Yeah. So that's a network configuration problem. A network guy made that mistake, right? Somebody got some bad advice. But the software that's running it is improbably complicated. It's very difficult for a normal human to configure any networking system normally. If you run a mid-range retail shop, you probably do not have a dedicated network staff. And yet you still need to keep all these machines running all the time, and you don't want to pay the $230 an hour to have the guy from down the street come over. So you're going to run it yourself. Yet the software is flawed. The software itself has injection vulnerabilities. I won't get into that with this, but that's neither here nor there. It is very difficult to manage, and you have to have an unreasonable amount of domain knowledge to keep it working. So we have two problems here, all basically driven by the software. So let's talk about command execution. There's probably a logo or something I should throw up. Oh, yeah. What is with that, anyway? The logo thing? I mean, back in my day, we didn't give our vulnerabilities logos and fancy names. I heard recently there was one of them, maybe it was this one, where they'd already registered the domain name before they submitted the vulnerability information. Which one was that? Was it Shell Shock? Yeah. So I think we're missing the point here a little bit. So anyway, Shell Shock, for those of you who, I'm sure you just went and patched, you might not know actually what the flaw was. Shell Shock is a bug in Bash. Can anybody tell me how old Bash is? There are people in this room that did not exist when Bash went to V2. I guarantee, I know for a fact. Yeah, like that one. Bash is like 32 years old. And somebody discovered that if you send an unusual set of commands, Bash does have a very unique perspective on what punctuation means. I will grant you that. But if you send an unusual set of punctuation to it, you can send an arbitrary command after the semicolon and it'll just execute it. Do you have any idea how many pieces of software running on the internet are underpinned by Bash? It is an extremely large number. And if your machine is even slightly misconfigured, then once again, a very, very simple one-line missed overread flaw in a piece of code that's 32 years old and has been available for viewing all that time, one line, take over the machine. That easy. See, I told you it'd be funner than Nickerson's talk. So we've, a lot of the people on the second slide lost user accounts. Of course, user accounts are a big problem because we don't want our name, address, and social security number to be available because that's, that's $350 on the dark web, right? Those are for sale. But getting our passwords is a problem. And for some reason, we still haven't gotten the idea out, even to very large companies, that you cannot store passwords in plain text. I do not know why this is so difficult, but it apparently is. We can know that because if we go to our profile, if you can see your password, that means they are storing it in plain text. For those of you who aren't familiar with hashing, there is no way to return a password from its hash back to the password with the exception of brute force. There's no algorithmical way to do that. So if they send you an email that says your password is, that means you need to stop doing business with that company immediately and do business with somebody else, even if it's a company like Tesco. I have no idea why. Oh, yes. So the reason why this is such a big deal, of course, is because of the SQL injection flaw we started with. The first thing they do is download the users table. If the passwords are stored in plain text, that means they can log in as you and be whoever you are. If you are sharing your password between sites, that means they can be you in many different places. This is no good. Fine gentleman named Troy Hunt has a site up, if you're not familiar with it, called Have I Been Pwned? It's literally haveibeenpwned.com. It is sitting up on Azure. It's an Ask.NET MVC site. He loads all the dumps into there. I think he's got 175 million accounts when I took this picture, which was a little while ago. You put in your email. It tells you what breaches you show up in. It's neat. If you haven't done it, do it real quick on your phone. I think it's got a mobile skin. It's very cool. And all you're doing is, I mean, of course, you can never be perfectly sure, but for those of you who haven't met Troy, there isn't a better example of ethical hacker than Troy. He's amazing. He's also really, really smart. So this is another example of the solve problem, right? We know how to protect passwords, right? We take the password, we hash it, and then we store it. And then when they sign in, we take the password, hash it, and compare it, and then throw it away. We don't need to store the passwords anymore. We already talked about the forgot password process. We don't send them their password. We replace it. There's a big document on the OWASP website that says, hey, here's how you do this, and yet we're still not doing it. Why? Because encryption is difficult. They will also occasionally point and say, well, even if I hash it, they can break it. I mean, look at LastPass, right? You guys hear about LastPass? They got popped. User tables downloaded. Bad news, right? Yeah, but you know, it's 5,000 iterations of PBKDF2. Don't think we're in too much trouble, frankly. Is it possible somebody could reverse those? Sure, anything's possible. But I don't think we have to worry too much. Adequately salting and hashing passwords is something that should just happen. Yet for some reason we have, major department store chains emailing you your password. Why? Hell if I know. Everyone likes customized websites. We want to upload our pictures, upload our files, do neat stuff. It's really cool. Whenever you allow a user to upload a file into your web server, you are setting yourself up for disaster. Of course, the most obvious version is, I can just upload a shell, right? That'd be the easiest thing for me to do. That sometimes is harder than normal. But it's amazing how many developers are still allowing file storage in the web root. If you allow an attacker to upload a file that's then immediately internet addressable, there is never any possible chance where something good is going to come from that. And yet we do it anyway. Why do we do it? Because creating indirect object references to files is difficult. It's demanding. We have to have the software done this week. We do not have the time to deal with this crap. We're just going to upload our file over here and then allow them to address it. And that's that. But we all know where that leads. So URLs are a terrible place to keep anything, right? The main reason is because they're visibly editable by normal users. And that's where you run into real risks, because the guys who are using burp or screwing around under the covers are bad enough. But when a normal user can look at the URL and say, I wonder. So I was doing a training the other day, and when I do big for like 2-day formal trainings, I always ask for credentials to one of the internal applications in Dev so that I can use it for my examples. So we're talking about injection, and I said. So I said, hey, okay, so let's pull up the site. I give them the basics of injection and say, let's pull up the site and see if we can find a cross-site scripting vulnerability. And the guys who had written the particular site I had are like sitting over on the side of the room, and they're looking at each other like, yeah, good luck, buddy. Good luck. So I said, so let's just put something in the search right here on the homepage. I'm not authenticated or anything, just on the homepage. Put something in search. So I put something in the search, pull up, the search comes up. Oh, good, okay. Oh, look, it's in the URL. So I wonder if I can just click on the field in the URL. And the guys over here, their smiles are slowly going down. It's like eyes getting bigger. So let's see if we can just throw an image tag with an on-error handler in there. Boop. Comes up. They're both like. Yeah, URLs are a terrible place to keep anything, and yet they're super, super convenient for developers. You know, we don't have to worry about the state of the application. We know that the user's got it going from place to place. So the chase thing. So here's the official thing. The official thing from the chase attack. If you guys are familiar with this one, it says using the Citigroup customer service website as a gateway to bypass traditional safeguards and impersonate Astro credit card holders, a team of sophisticated thieves cracked into the bank's vast reservoir of personal financial data until they were detected in a routine check in early May. They were keeping the account number in the URL. The attackers iterated it by 1, and then 2, and then 3, and then 4. And there was no direct object authorization. Obviously, some other things had to go wrong to make this happen. Obviously. Yet, you simply do not store things in the URL that relate to the current session of the user. Ever. You have to look it up each time. This is for those of you who don't regularly do vulnerability analysis on web applications, this is one of the easiest things in the world to look for. If there is a bunch of crap in the URL, other than something directly referring to what's on the page at the moment, anything referring to the session of the user, tell the developers to go back and try again. It's the easiest flaw in the books to discover, and basic users are going to screw with it, which makes it even more dangerous. Oh, I'm sorry. I was supposed to have that up while I was talking about that, but that's okay. You get the idea. So, especially with REST APIs. Did anybody at Cleveland OWASP hear my REST API talk? I know a couple of you did, so yeah. So we spent a lot of time talking about the language API during that talk. With REST, right? With these web service-driven applications running on Backbone or Angular or whatever, when we expose a REST API like this, we are giving an attacker unfettered access into the core being of the application. They can discover how the application works by just simply viewing the communication between the JavaScript in the web browser and the web server running the services. So it is incredibly important to constrain that information as much as humanly possible. Now, you can only do so much, but you need to do everything you can. I'm running out of beer. I'm drinking like half of it, and then half of it, and then half of it, and half of it. Eventually, I'm going to run up against the laws of physics. Buffer overflow is the oldest flaw in the books. It well outdates web software. Buffer overflow is often how we bypassed copy protection back on Apples back in the day. That's because they all had buffer overflow flaws, and a very easy way to make the application behave in an unexpected way. The vulnerabilities we discover now are often operating system vulnerabilities, right? So look at like Code Red and Nimda. These worms that travel through taking advantage of buffer overflow in underlying server software. Ooh, I'm running out of time. So the unrestricted buffer overflow in IIS that was exploited for one of those, I don't remember which one, was patched in 2003, and yet that is still one of the core pieces that one of the big incident response companies in Columbus still has to go and clean this off servers with regularity. Insufficient encryption and randomness. Developers like to store information in their session. And they don't realize that we can discover that very easily. But the concept of the session requires that round trip to the back end. And the developers don't care to make that trip if they don't have to, so they'll keep extra information in the sessions. Session identifiers should be cryptographically random and nothing else. Easy problem to fix, yet it's still out there. I have a funny story about insufficient authorization, but I'm running low on time, so I'm going to keep it short. So there's this voting platform, right? A web-based kiosk voting system. I'm sorry, web-based, not kiosk voting system. Allows you to go to a website and vote. And there's all this two-factor authentication, and you had to get a code in the mail and everything like that, and it would walk you through there, unless you just directly access the voting screen by typing it into the browser URL. And then it assumed you were the first user in the database, who was the admin. That's a real story. I'm not allowed to show anything, but the guy who discovered the vuln showed it to me. Well, we think he discovered it. The first good guy to discover the vuln showed it to me. Yeah, so that gets the triple face palm. So quickly, some closing thoughts, right? We're all worried about the NSA being able to like break SSL and all this encryption and stuff. And all these obscure flaws in Tor. But the fact is, what's most dangerous in Tor is the applications that are running on the hidden services themselves. These web apps that are just as flawed as the public web applications, right? When you discover flaws in applications, I don't need to tell this crowd to carefully consider how you disclose it to the companies that you're disclosing to. This is not my original crowds for this. I need to tell the two. You don't need to hear that. You probably know that. But keep your eyes open. You guys, even if you're not in the internet space or in the application space, your vision into how security works will help us keep our applications more clean. Keep in mind, guys and girls, I'm sorry, keep in mind, folks, that what we're trying to do here is make everything safer for all of us that are sitting around our devices doing what we do every day. That's what we're trying to do. That's the key piece of this. Make a quick pitch out of here for OWASP. I've got a couple of Cleveland OWASPers in the room. Open Web Application Security Project. Open Web Application Security Project. There's a Cleveland chapter. There's a Columbus chapter. We get together and talk about this stuff once a month. It's good times. I have run out of time. Thank you very much. I hope you enjoyed yourself. I'm at Sempf on Twitter. Feel free to throw me questions. And I'm sorry I left the next speaker only 2 minutes. Thank you very much. Oh. You're the next speaker.
Yeah, no, I was still giving you a hug.